So here we're doing the 4.5 proof trigonometric identities. Now, you know Pythagorean theorem, right? So if you have a right angle triangle, see this is A, B, and here is C, hypotenuse. Say the angle here is theta. You know A power 2 plus B power 2 is C power 2. These are the legs that make 90-degree angle. The square of them, add them together, is equal to hypotenuse power 2. So sine theta is B over C, right? Sine theta is B over C, opposite over hypotenuse. Cosine theta is adjacent over hypotenuse, is A over C. What can I do here? I can divide each term by C power 2. Here's C power 2 divided by C power 2. Then this is 1, right? And here I can bring them together. I can bring it as A divided by C to the power of 2. When you put them in the bracket, means this power is belong to both of them. Means this is the same as A2 divided by C2 plus B over C power 2 is equal to 1. We know A over C is cosine. So cosine power 2 theta plus B over C is sine. Sine power 2 theta equal to 1. So this is the Pythagorean theorem identity. Sine power 2 plus cosine power 2 is 1. There are other identities that we can prove in the same way. We did it in grade 11. I just did an example for you. So we have that. So we can accept this one. Later on, you want to prove any identity, you can use this. As already know. Very important one. Now, the other identities is 1 plus tan power 2 is sine power 2. 1 plus cotan power 2 is cosecant power 2. Now, you don't really need to memorize that one. We can actually prove that easily. But here that is listed on the left is important that you memorize that. Tan is equal to sine over cosine is quotient identity. Reciprocal identity. Cosecant is equal to 1 over sine. Secant is 1 over cosine. Cotan is 1 over tan. And compound angle formula that we have done before. Sine of addition of two angles, you can write it, or subtraction, you can write it and expand it like this. We did it in previous class. So let's just do an example. See, the example is tan theta is equal to sine theta plus sine power 2 cosine theta 1 plus sine theta. Okay, what I do, let me just a little bit do that. I divide my paper into two. So I write the left side, which is tan theta. And I put a line. So I divide my paper. At the other side, I put the other side, the right side. Don't put equal between them, right? Because you want to prove that. You want to prove means you have to show the right side is the same as the left side. Divided by cosine theta 1 plus sine theta. So whenever you see secant, cosecant, tan, cotangent, you need to write it down in sine and cosine because the other side is in sine and cosine, right? So tan theta, you know, is sine over cosine. Now I need to simplify the other side. You cannot simplify this one more. This one, from numerator, I can factor sine theta, right? If I factor sine theta, First term divided by sine is 1. Second term divided by sine is sine theta. Then in denominator, we copy whatever we have. See the bracket from top and bottom, they cancel, right? 1 plus sine, they cancel each other. True. And whatever left here is sine over cosine. Do we have the same thing on the right side and left side? Yes. So we prove that the left side is the same as the right side. Any question, Theodore?
No, I can get a screenshot.
Okay.
Yeah, I can.
You didn't? Now, the other one, there's one more example here. We do the same thing. We write the right side and left side and we work with each side separately. Then at the end, you show they are equal. So here we have sine theta power 2 minus cosine theta power 2 minus tan theta power 2. I put a line. At the other side, we have 2 sine power 2 theta minus 2 sine power 4 theta minus 1 minus sine power 2 theta. Okay. We can work from this side. So tan, I can write tan as what? Sine over cosine, right? Because everything is sine over cosine. It's better that we turn everything into the sine and cosine. Minus cosine power 2 minus sine power 2. Because this is a power 2. I know tan is sine theta over cosine theta, but since the power is 2, I need to put the power, right? Now I'm taking common denominator. The denominator for these two terms is 1. Means I need to multiply numerator and denominator by cosine power 2 theta, right? So multiply by numerator by cosine power 2. Multiply by cosine power 2. Minus multiply this one by cosine power 2. It becomes cosine power 4. Okay. And multiply this one, you don't have to multiply by anything because the denominator is cosine power 2 already. Minus sine power 2 theta. Okay. Divided by cosine power 2 theta. Now see at the other side, everything is in sine, right? I need to turn my cosine to sine. Remember, sine power 2 theta plus cosine power 2 theta, it was equal to 1, right? That was a Pythagorean identity. Means instead of the cosine power 2, if you rearrange it for cosine power 2, you can write it as 1 minus sine power 2. So whenever I see cosine power 2, I can put what? 1 minus sine power 2. Since this is cosine power 4, see cosine power 4 theta is cosine power 2, then to another power 2, right? Then instead of cosine power 2, you put 1 minus sine power 2 power 2. So instead of the dot, I put 1 minus sine power 2 power 2. Then I expand. Now in the next step, I'm going to expand them. So sine power 2 multiplied by 1 is sine power 2. Sine power 2 multiplied by negative sine power 2 is negative sine power 4 theta. Now, this one power 2 is the first one power 2, and I have a negative 1 power 2 multiplied by negative at the behind is negative 1. Twice of the first multiplied by second is 2 sine power 2, but because there's a negative at the end, become positive. 2 sine power 2. Theta, and and sine power 2 to the power of 2 is minus. Should I have to put minus here? Where's my pen? Okay. Theta minus sine power 4 theta. And the last term here is negative sine power 2. And now I put it very small. Sorry, I didn't have a space. Power 2 theta. And the denominator is cosine power 2. Now we can simplify. Oh, instead of the cosine power 2, I need to put what? 1 minus sine power 2, because at the other side, everything is in sine. 1 minus sine power 2. I need to simplify. See, sine power 2 theta and sine power 2 theta here is minus, and the other one is positive. They cancel. These two cancel. We have 2 sine power 2 here. We have 2 negative sine power 2. Okay, so this is 2 sine power 2 theta. Negative sine power 4. Negative sine power 4 is going to be negative 2 sine power 4. And we have negative 1 divided by 1 minus sine power 2 theta. Do we get the other side? Yes. See, exactly, I have this one. So we conclude that the right side is equal to left side. And we did prove that. Any question?
No.
Theodore, any question?
No.
No, okay. I'm gonna erase this. That was the last one. Now, there is a worksheet. I did send it to you, 5.4. Let me just pause it for a second. Okay, so this is proof trigonometric identities worksheet. I want you to start. So I'm expecting a student to do all of that in class, but let's see how much of this one you can do. And 45 minutes I'm gonna give you to start doing it. See, for the cosine of 2x, this is a double angle formula. You can use cosine of 2x is equal to 2 cosine, is cosine power 2x minus sine power 2x. You start from that. And then you see everything here is in cosine. So you have turned the sine to the cosine using the Pythagorean identity. The same thing, you start, same thing, and see what you have at the other side, and you think about what to do. This is the double angle, right? This is the one that you have a compound angle formula. You need to use that. Again, compound angle formula. The first ones are easy. So all of that is compound angle formula. This one, easy. Just turn cotangent to the sine cosine things. I think the rest of that is reasonably fine. So start doing it. I'm gonna look at your work and I do a couple of that with you later on.